Welcome everyone. First, super excited to be here on this platform. So, thank you, Vijan, and thank you everyone at PM Exercises for giving me this opportunity to get in front of all of you. So, thank you. Um, I know the topic is called privacy compliant AI, but what I'm really going to speak about is on-device machine learning, and that's one technique of how you build products in today's privacy sensitive world. So you'll see me touching upon aspects of privacy, but on-device machine learning has many more applications and uses beyond just privacy, and you'll see that. Everything I speak about today is just a tip of the iceberg for folks who are not aware of this concept, who have never heard about on-device machine learning. I want this to be an introduction so that you're curious enough to start poking around and look for more materials. So this is just going to be extremely non-technical, very simple to understand. Again, a 10,000 feet overview of what on-device machine learning is. So hopefully it's exciting. Hopefully it's you've started your Friday morning and you leave this session on a note having learned something new. That's my goal for today. What to expect? I have a couple of slides, as you can see. So I'm going to be speaking maybe 15, 20, 25 minutes. I don't know how long that might go. There isn't a whole lot of content. Just like I said, it's intro level stuff. And I want to keep this informal. So I want to leave enough time for questions. I want to leave enough time for thoughts. If anyone kind of just had a random idea and thought and wanted to just put up their hand and express, please do. Again, like I said, I'd love this to be interactive. For any burning questions, please raise your hand during the walkthrough. This does not have to be my monologue and then everyone listening. I'd love this to be a two-way discussion. A little bit about me. Jacqueline, by the way, thank you for that introduction. I really appreciate it.
Yes.
But yeah, I am a product manager, and something unique about me, I have very strong, versatile product management experience. So if you go through my LinkedIn, you'll see I've worked in very popular B2C and B2B companies by now, and they've been in all different stages. I worked at a large financial services company, then went to a fintech startup, a really small one, then went into tech, a Series C startup, then went into the big tech. Now I'm back into like a large enterprise social media tech company. So it's been really versatile. I'm really grateful. There's been lots of good learning. And today I'm sharing a piece of some of what I have learned through my more recent AI/ML product management experience. Anyways, enough about me. So what's on-device ML? On-device ML is also known as client-side ML. It is also known as federated learning. So after you step away from this discussion, if you want to continue learning, those are some of the keywords you want to look for. Client-side ML, federated learning. But essentially, these are machine learning models that are built on servers, but they ultimately live on client. And what I mean by client? A client can be a user device, your smartwatch, your smart speakers, your car, your smartphone. This is where these machine learning models are actually living. So big companies, think Amazon, think Meta, think Apple, they're all developing these machine learning models on their sophisticated servers and then pushing these models to your devices so that these machine learning models are learning from you as you go. They're tweaking what the experience that they want to give you, and that's why you enjoy your devices so much. um, a little secret, these Zoom calls with virtual backgrounds also have some amount of client-side ML or on-device ML on them. So maybe this is a little bit of homework after this session. Feel free to use your favorite AI tool, if it's ChatGPT, if it's Claude, if it's Perplexity. Maybe let's all take this as an assignment to go learn, hey, where's on-device ML involved here? But anyways, so on-device ML is really promising. I know we headlined this discussion as privacy compliant AI. So yeah, one direct application of on-device ML is privacy. Other benefits are lower latency. So the time it takes for a machine learning model to throw a result, an outcome, an inference at you is going to be much shorter when the device is living locally on your, the machine learning model is living locally on your device. There's no server involvement. There's no reason for a machine learning model to do complex computations and processing, hence the lower latency. Again, with less power consumption, the whole architecture becomes less cost effective. It becomes more cost effective. And like I said, these models are with you, they're on your devices. So they are learning from very, very nuanced individual user data to continue learning and deliver extremely personalized experiences. And you'll see as I'm going through this content, more and more of what I'm speaking right now will start making sense. So how does this really work? Like I said, these models are developed on the server, ultimately deployed on the client. So if I had to give you a walkthrough of what essentially happens from step 1 to step 5, essentially your device downloads this model from the server. It starts working right off the bat, but it slowly starts learning from the data on your phone and starts improving itself. However, in the real world, what's also happening is it's summarizing the changes on the go as a small focused update. And then these small updates from individual user devices are sent to the cloud, where imagine on the server, this model does go through one round of iteration. The training data always remains on your device, but there are also always improved versions of these models that keep making their way into your device every couple of months. And essentially, like I said, your phone personalizes the model locally based on your usage. And almost everything is local. The device is learning from user patterns. There are local model updates, like I said, that are communicated to the cloud. The cloud server updates the global model, and these new models keep coming back to your devices. Let me actually speak through a real world example, a product that I built at Meta, which actually leveraged on-device machine learning models. So this is a story of my time from Meta, where we were able to leverage on-device machine learning to keep children safe on private messaging apps. More specifically, I'm talking about Messenger and I'm talking about Instagram Direct. So Instagram Direct is the chat experience within Instagram. This unfortunately still happens, but around 2021, 2022, we already knew that sextortion, which is essentially extorting money from children, financial extortions via intimate image abuse, had become a huge problem on social media. Unfortunately, it still is, but companies have started to do something about it. And what I'm sharing right now is where on-device ML actually is actively playing a role. And the idea there is leveraging on-device ML to minimizing exposure to any kind of unwanted nudity. Now, this is interesting because in a non-privacy world where everyone can look into all the messaging data, companies have used server-side models where you can look into messaging data. However, more and more chat applications are now going end-to-end encrypted with the popularity of WhatsApp. And that means messaging applications can no longer look into what are the conversations between two people. Is there someone creepy on the other side that a teenager might be engaging with? Are they being sent nude images? Are they being coaxed into sending their own images that might contain some form of nudity? Are those images going viral without consent? Social media companies have unfortunately no way of telling what's going on. It's really difficult to keep people safe. So how do we minimize this exposure to unwanted nudity without looking into user data and leveraging machine learning? That's where the privacy compliant AI comes into picture. So this is AI that won't send data to servers. This is AI that lives and operates 100% on the user's phone. No intervention again by servers to keep that privacy constraint in mind. The experience you want to give a user is like they're in their living room having the most private conversation, but we are still going to keep you safe. If you actually turn on the safety control today in Instagram or Messenger, you'll notice an experience like this, which is as a receiver of a message. If you received an image and you've turned on the safety control, essentially there is a client-side machine learning model or on-device ML that is running on your phone and scanning every single image that you receive And should the model believe that there is some nudity on your phone, it's going to blur that. It's going to put a message on top saying, hey, Ricky, this message contains nudity. This is a perfect example of AI for good, on-device machine learning for social good. So how did we go about this? How did we actually land on this solution when we were thinking through how do we leverage machine learning models at the same time be privacy compliant? There were two approaches ahead of us. One was we still go to the servers because server-side machine learning models are large. They can be computationally complicated. They give better performance. There's a better chance we can keep people safe. That approach was going to require scanning images in messages, maybe computing a hash of this image, and you send a hash back to the server instead of the actual image. And you compute these hashes to a pre-computed database of known nudity on meta servers. This unfortunately was not going to be privacy compliant. So Apple had attempted something like this back in 2019 or 2020, I don't exactly remember. But that approach was heavily criticized by regulators for not being privacy compliant. And as a response to that, Apple had to completely pull back all its efforts towards protecting children from sexual abuse material. So we don't want to go that route. We didn't want to get caught up in regulatory and compliance and excessive privacy regulation where we are not able to keep children safe. So an excellent way to hit both privacy and safety for users was on-device ML, was client-side ML. And this is what I'm referring to, where machine learning models were built on the server, but ultimately we deployed them on an iPhone, on an Android phone. So these models live locally. We had consent from the user. So even before we deployed these models to the user's phone, we actually subjected them with a prompt saying, hey, your chats are end-to-end encrypted, and here's everything that's going on. We noticed you're a teenager. Here's everything that goes on. Would you like to turn on the safety control on for everyone who says, yes, keep me safe from any unwanted nudity? A machine learning model is deployed to that user's phone. This lives completely on the user's phone now. It's 100% privacy compliant because no entity has access to any messaging data or images that are exchanged between two people. What is limiting is that the model performance. So in terms of recall, it may not cover as much because these machine learning models are much leaner. They are much smaller. They have computation that is as limited to the resources, the hardware on an iPhone or an Android. That is so much more limited than what is available on the server. So is there a possibility that the machine learning model, in this case that is living on the client, fails to catch something that contains nudity? Is it possible that it falsely flags something to contain nudity? That is absolutely fine. Yes, that is a limitation of on-device machine learning model in this specific application. But it is some protection compared to no protection in an end-to-end encrypted world. The one thing that companies are always working towards with on-device ML is also you want to make sure that you don't want to degrade the performance of the actual app. So in this case, right, these models are on Messenger, they are impacting Instagram. At no cost do you want to slow down the experience on Messenger. I don't want to slow down the experience on Instagram. That the user is so frustrated that they just opt out of these controls, or worst case, they uninstall these apps, they bounce off to other social media platforms. So that's kind of the one thing that the growth and engagement teams are always concerned about when it comes to any safety related machine learning model development. Just something to keep in mind. This is actually a workflow of what really happens. So on the left is a user who, like I described, if you start following the numbers here, then he's this user, they have given a user consent to say, yes, I am okay with a machine learning model being deployed to my phone. With that consent, that machine learning model is deployed. They start using the app as usual. Every time the machine learning model actually finds nudity, the user actually has an opportunity to long press on that image and start collecting feedback or signals, or start providing these to an Apple, to a Meta, or whatever that app might be. So this is again one thing that's extremely important to do when you do some kind of on-device machine learning model development, which is capturing signals from the user. You want to know from your end user if all the model inference that you're essentially delivering, did we get it right? Did we get it wrong? And you want to capture these user signals and make them a part of your training data. As you continue to gather this training data, periodically you want to refresh your machine learning models based on the user signals that you aggregate across a large set of users. When you're convinced you have significant shift in your training data, that your machine learning model performance is going to significantly improve, you want to retrain your machine learning model, and you want to send that refreshed model back to the device every 3 to 4 months. So that feedback, that user signal is very, very important to make sure you keep that evolution, you keep that development going on. But like I said, on-device machine learning modeling is just so much more than user privacy. The one thing that we've spoken at length, I probably mentioned this a bunch of times, personalization. These models are living on your phone. They're constantly learning from you, how Prachi is engaging with this model. What does she expect out of a user experience? What is the experience I want to deliver to her? In the same example that we spoke about, right? Protecting people from unwanted nudity. Nudity itself is so subjective. Someone sitting in Turkey, someone sitting in the United States, someone in the Far East, we all interpret nudity very, very differently just because we come from different cultures. So one day we want to have machine learning models, anything in the safety realm, to also learn from people how do they interpret nudity. And these machine learning models should be personalized, and they should understand that, hey, something's okay with Bijan, but it's not okay with Prachi. So I want to make sure I respond differently based on the different user and keep them safe based on what they expect safety to be. So personalization is a big one. Because there are no costly data transmissions between client and server, everything is local on the client. There are a ton of cost savings. Again, the fact that it's local, it's highly responsive, it's going to adapt to real-time user behavior. So those are kind of the benefits that, again, go beyond just the privacy aspect. We already spoke about this, but in terms of trade-offs, on-device machine learning models are not perfect. We don't have unlimited resources like you would if these models were living on the server. There's very less computational power, very less that they have to do with. And that means restricted performance. By performance, like I said, it could be, again, in this specific example, could it miss something that's genuinely nude and should have been blurred, and the model just did not blur that image? Yes. Could it just get over conservative and like a false positive comes up where it blurs something that's totally fine and safe? That's possible. You obviously want to, again, going back to the aspect of collecting user signals, collecting feedback, having really high quality training data sets, high quality evaluation data sets to make sure you're minimizing those false positives, and that you have recall that can come as close to server performance. So it's a cycle, it's an evolution. You continue working that muscle on your machine learning models as well. Same thing, limited computing resources. There are strategies though. So apart from what I just mentioned in terms of having really high quality training data sets, evaluation data sets, and collecting signals, there are smart things that can be done within machine learning principles itself. So one of them is quantization. With quantization, you actually intentionally reduce the precision of the machine learning model, and that speeds up the computation, and that also decreases your model size. Again, a small model size is important so that you are not degrading the performance of the app itself. So typically machine learning models that are on device need to be somewhere under 100 MB or 200 MB. And quantization helps you do that. But again, the trade-off you make there is you intentionally reduce the precision of the model. The other strategy is pruning, which helps you preserve your phone battery, because now you're also looking at a much smaller memory footprint. A memory footprint small enough for devices with smaller RAMs, right? Smartphones. So in order to make sure your models are executing fast, there are fewer computations, you require less storage, you conserve the phone battery, pruning is the other strategy. Some more challenges. So data sets are restricted, right? Like a machine learning model that lives on Prachi's phone is only until, of course, you're refreshing these models as a part of a larger effort. But until then, they are only learning from single user level data. It's only learning from Prachi's phone, for example. Also, you are launching these machine learning models on an Android phone, on an iPhone, and many other heterogeneous systems, right? So that requires you to keep in mind what might be a sophisticated technology stack that will make it possible for me to deploy this machine learning model to millions of devices. Also, these devices are in countries with different network bandwidth. In the United States, it looks something else. In a remote village in one of the emerging markets or an underdeveloped country, those challenges are going to be very different. They are probably not going to have as sophisticated phones as we do here, or the network bandwidth might be really different. So that's again a constraint, a challenge to keep in mind. Also, as more and more devices now will be at a threat of theft or destruction, as entities start to learn that there are actually smart AI that is living on the phone, and these phones or these models are so personalized that they just know so much more about the user. So as these specialized AI models get deployed and this becomes more and more popular, there is a threat of theft. One thing is PMs that we should keep in mind. Metrics, measurement is a huge one, right? Measurement via traditional analytics is not an option. So historically, or traditionally, how we measure when machine learning models live on the server is really straightforward, right? It's all on the server. We have access to user data. Let's go back to that example that we were talking about, right? A machine learning model that lives on the user's phone and it's trying to minimize exposure to nudity. Now, in this end-to-end encrypted context, it's not easy for me to tell if the prevalence of nudity has truly gone down, because I cannot look into individual messaging chats and tell if has there been any lesser exchange of nudity with the deployment of this machine learning model, or are we actually minimizing sextortion? Can we actually stop any kind of sextortion from happening now that I have an on-device machine learning model? So because of this kind of privacy layer for that specific example, when on-device machine learning models are used to offer privacy, performance measurement can also become very difficult. How do we measure without looking into user-level data? Again, one kind of concept that I would love for folks to, if again this is interesting, then you should definitely poke holes into, it's federated analytics. And the concept is really simple. You run local analytics, and at a certain checkpoint, you aggregate all of this data. You have some kind of a central coordinator, and you aggregate data. Obviously, you're scrubbing any individual data that might be at the risk of like exposing PII or any kind of personal data. So you leverage some kind of secure aggregation methods. And then you also add some controlled noise to these aggregated results. That way, data remains fully private. But federated analytics is one strategy to make sure privacy compliant AI models still have a way of being measured without looking into individual user data. And what's happening right now as we speak? What are some things that I am aware of when it comes to on-device machine learning and Gen AI, for example? So Apple, as we speak, they are developing their own large language models that are going to run on device. They already have large number of teams that focus on device, by the way, but with LLMs, I'm sure they are heading in different interesting directions. Obviously, with our future evolution of iPhones, we'll see quicker response times, even more superior privacy compared to cloud-based solutions. So something to watch out for. And a lot of examples that we are already seeing with generative AI, image segmentation, image generation, live translations, super resolution, where you can improve image clarity and sharpness. A lot of that leverages on-device machine learning. So again, something if you want to continue poking holes into, like, what are the real world applications and where might on-device ML be a part of my regular daily life, then those are some areas that you can start looking into. If you want to continue learning more, I've listed some resources. Like I said, just search for federated learning and you should get a lot of material. Deeplearning.ai, this website has a wealth of information. The one that I found particularly interesting, if you actually wanted to get your hands dirty and build a machine learning model, if you're that technical, Qualcomm has an on-device AI course there. It's absolutely free, which is amazing. And Harvard has actually recently published a book on machine learning, and then they have a specific chapter on on-device learning, which again captures a lot of these details really, really well. They go in much more depth than I can. So again, depending on your technical aptitude and how much more you want to continue digging into this, I highly encourage looking into these resources. Um, and if you want to talk to me about just AI, ML, data, I love talking about this stuff. So feel free to reach out on LinkedIn, connect with me. I'm happy to do like a virtual coffee or just anything if you want to chat about data, AI, ML. Um, and with that, I'll stop. Like I said, I just wanted to keep this really high level. I would love to hear any thoughts. I'll try my best to answer any questions, but anything else apart from everything that I covered, I'll take questions.
Wow, you did such a good job. That was so interesting. I loved listening to this.
Thank you.
Yeah, of course. It was awesome. We do have a few questions in the chat. If you don't mind, I could just read a couple of them. Okay, so here's one question. Um, so if model is getting real-time data through user feedback to continuously learn, then why does it get outdated?
Where can I see the question actually?
It's just in the chat. Do you want me to read it one more time?
Why don't I look at the chat myself? Actually, do you mind reading it to me
Of
once?
course, yeah. So if a model is getting real-time data through user feedback to continuously learn, then why does it get outdated?
Yeah, so again, the model refreshes, from my understanding, happen every few months. Um, they can get outdated based on, again, like the training data is just so limited, right? Like in this specific example, if you're looking at the slide, this model for Ricky on Ricky's phone is learning from any feedback that Ricky has in real time. But there could be a Prachi, there could be a Jacqueline, there could be a Bijan in the real world who also have some good feedback to share. So what's important is that you aggregate these user signals across multiple users. And that aggregation is what I believe you want to give a dedicated a month or two. Typically, what I've seen, 3 months is a good time to collect data across a diverse set of users. That way, your machine learning model is fairly comprehensive and representative. Like the other aspect to keep in mind, I'm sure you've heard of this, is also not introducing any kind of bias, models that are responsible, fair, comprehensive, representative of different kind of user groups. So while machine learning models are capable of learning on the user device themselves and with that real-time feedback, the workflow that I'm describing here is where you want to aggregate feedback from different users.
Super interesting. I love that. I have a couple more questions. So here's the next one. Can you give examples of products using federated learning?
There are a few here on this slide. So the one specific example that I directly worked on, again, is this one where we deployed a machine learning model as a part of Instagram and as a part of Messenger. And this was all federated learning because we were not allowed to look into the images that were being exchanged. So as a server side model, we were not allowed to look into messaging content. So in this case, this model lived on the user's phone. The entity, which in this case is Instagram, had zero idea about what's like whoever Ricky is chatting with here, right? We have no idea what's going on. Everything's happening locally. So this is on-device ML. And then here are more examples. The whole Zoom virtual background thing apparently is on-device ML. And yeah, your Alexa, right? That's on-device ML. Bunch of other smartphone applications could be. There's a lot on your automobiles that is on-device ML, by the way. Smartwatches. So yeah, this could be a fun little workout after this session, maybe to go start poking into where is on-device ML buried into these applications. Sorry if I'm just repeating myself, but the example that I can speak to in detail is definitely this one, since I like myself spent 9 months working on it. So yeah, this one I can talk in detail about in terms of an application of on-device ML.
Perfect. We have one more question here in the chat. Where did it go? How do you evaluate these models or benchmark?
Yeah, great question. So federated learning, like I said, federated analytics is the ideal route you want to go. Like for this specific example, we should have, at the time, we didn't have the luxury, as odd as it sounds, things can get really scrappy and restricted even in larger tech companies. So for that specific example, I never got to the federated analytics part where without looking into user data, you're still able to tell, did we actually minimize exposure to nudity? Did this actually work? So in this specific example, we couldn't do it. So this is what happens in the industry if you want to measure performance of machine learning models in a privacy world. In this specific example, what did we do? We actually used adoption of the safety control as a proxy. So this was an optional safety control. It was something that users had to give us consent and opt into, since there's privacy involved here. Whoever opted into this control and continued to stay beyond, let's say, 7 days or 2 weeks, we took that as a success metric and we said, this must be working since people continue to have this safety control on. And then, of course, you want to, do focused user groups, right? So in this specific case, there are parents, there are teenagers, in the US markets, in the Mexico markets, in the Canada markets, where this is such a huge epidemic. So we actually did some focus groups. There are also a bunch of youth safety, child safety nonprofits in the United States who reviewed this. There was Howard University, there was a National Center of Missing and Exploited Children who reviewed this solution, and they had some feedback to share. So you do those things as well to get your qualitative stories. But in terms of like just measurements and analytics, ideally federated analytics. If that's not an option, you want to find some proxy metric to know if this is working.
Perfect. And Chaitali left another comment back to her previous note. So she just said there's a difference between federated learnings and on-device ML. What are your thoughts on that?
Oh, I was actually not aware. So I'm happy to go after this and, kind of find out that for myself. But thank you for flagging. Thank you for flagging.
Yeah, of course. And then we also have another from Mandeep who says, what are the steps you took after you identified a person who is sending nudity messages?
So if I'm understanding this question right, what other steps do we take once you actually identify someone? Okay, so through this, so two things happen. one is, so let's speak in the context of this person, right? Again, one thing that I don't like about on-device ML personally is the onus is on a Ricky, or the onus is on the user to now actually report the person who might be subjecting them to unwanted nude pictures. But as a company, as an entity, as a product owner, you can make it really easy for a Ricky to report such users, to block such users. So that onus is on me, or the product owner, the product team. So that's what happens. Once Ricky suspects that this is kind of something that might be heading in the direction of me getting groomed, or maybe there's some ill intention here, they should be blocking the user. They should report the entire conversation to an Apple or to a Meta or whatever app that it might be. And only if an entity has the permission from the user to look through the chats can we take action against a bad actor. And that's the constraint of an application that is end-to-end encrypted, where the onus is really on the receiver to keep themselves safe. But you use on-device ML to give them the education, to give them the warnings, to give them the prompts where, hey, your safety might be compromised. That's something that you can offer with on-device ML. In terms of taking action, that is on the receiver or the person who's getting subjected to unwanted nudity.
Okay, perfect. So I believe those were all the comments we got in the chat. So we still have a few minutes left. If anyone wants to leave any more comments, feel free to do so in the chat, or you could either unmute yourself and ask them out loud.
Jacqueline, this is Vijita. I've had my hand up for a bit,
Oh, I'm
so I'm just
sorry.
going to
Yeah.
go ahead and ask.
Okay.
Prachi, thanks for the presentation. And I think you might have covered two of my questions in some bits and pieces already, but I'm just going to ask them. So the first question is, you use the word like user signals quite a few times, and I think that's a core component of training. What would be like some examples? And the second is that in your experience, what adoption tactics have worked best or strategies have worked best? Because as you said here, the onus is for literally the user to adopt this, for this to be able to kind of, especially in the case of like Instagram, to prevent nudity, or they being able to see, they being protecting themselves.
Yep. And I'll stick to this example, Vijita, but thanks for those questions. So in terms of capturing user signals, if you look at that screen, bottom left, you'll see the image is blurred, and then there's a warning called photo may contain nudity, right? As soon as that happens, the receiver of that message has the option to long press on that image. And the minute someone long presses, there is a prompt, which is a thumbs up or a thumbs down. And they have to either pick a thumbs up, which means, hey, Instagram, you got this right, a thumbs down, hey, Instagram, you got this wrong. And that's the lowest level of signal that you can capture from the user. And then, of course, there can be more descriptive things. You can do surveys, like once in 6 months, you could subject someone to a survey asking, has this been useful? If not, are you willing to tell us kind of what's working, what's not working? Like you could just do a user survey. You don't want to do too many surveys and create an annoying user experience. But you can make it really simple for someone to give you feedback with a simple long press, thumbs up, thumbs down, and that's something than nothing. And then you can always do focused user research studies, assuming you're starting with like A/B experiments. It's always quite doable when you are in a A/B experimentation stage to do more focused research as well. In this particular case, we also have the luxury of working with lawmakers and enforcement agencies and kind of nonprofits that work on youth safety, child safety. You have a little bit more there to play with in terms of getting user signal beyond the actual end user. Sorry, I forget your second question. What was about the adoption?
Yes, adoption, because you said like the user has to activate it. So one idea I had, like if you're working with a social impact organization, you can kind of use their communications to educate, your potential audience about this feature. But just like in app, what are the other things that can help aid the adoption of something like this? Because I think like if somebody gets a message, hey, there's a new feature, adopt it, there might be some skepticism or like, a privacy concern, although here you're trying to help the person.
No, and I think I'm glad you asked this question because this was one of the hardest challenges because it's so easy for people to ignore these prompts.
Yeah.
We started the typical way. We also had a prompt on top which said, here's a new safety control that Instagram has launched. Would you like to turn it on? You obviously just make it easy for them to turn it on with a big blue button which says turn on and then a gray button which is ignore. So you use some of these visual tactics, and then assuming they turn it on, this is on you now to make sure your on-device ML is not degrading the experience of the app, that they get frustrated and they turn off. That was kind of one place where we knew we had to put in a lot of the meat of this product development, which is the model has to be invisible. Anything that's happening in terms of scanning, in terms of model trying to draw out an inference, no one should be even able to tell. There should be no slowness in the app. So I think that's an area where you can put in a lot of product development effort to make sure the app experience doesn't become frustrating. And then beyond that, for a problem like this, it's education, education, education. Like even in that prompt where you are saying, hey, this is a nudity control that we are launching. Here's why you want to turn this on. Again, you are running the risk of someone ignoring these messages. So you also want to then have some strategy around how many times you want to remind them. So let's say a prompt has been, like you've subjected someone with a prompt once. If they explicitly say ignore, then from what I know, like Meta, for example, has this strategy where once they have said ignore, you don't want to subject them to that reminder again for, let's say, another 3 months. But if it's something that they have never responded to and they just close the app, maybe you can, twice or thrice, you can continue reminding them that the safety control is on. So having some kind of a rollout strategy, which is, hey, unless the user is explicitly telling us they are not interested, how many times can we remind them? How can we make it easy for them to turn it on? What kind of education materials can we offer to them? What are the outside off-platform things that we can do?
Okay.
Once they turn it on, how do we make it, I wouldn't say impossible, like you should always have a way to turn off something that was turned on. But how do we almost convince them that they need this? And without this, it doesn't even feel good to be on Instagram. So those are the few things. But again, by no means I want to claim that we solved that problem. It was always a challenge, especially with that community, like the young users who always want control over their experience and they don't want to feel like their privacy is being violated.
Great. Thank you so much.
Okay, we have another question in the chat. So it says, how can I build and use a small on-demand advice ML model on my own as a side project?
Ooh, yeah, this is what I was talking about. So this is something that I personally want to also do. Do check out deeplearning.ai. There is a small course there by someone from Qualcomm. I don't remember their name, but this is a person from Qualcomm who's been doing on-device ML for a very long time there. And they explain kind of what on-device AI is, but they also have snippets of code. And there's a simulation of like how to do this by yourself. So feel free to check that out before it becomes some kind of a paid course. Maybe this is a good time to go to deeplearning.ai.
Awesome. I think we have time for one more question if anyone wants to unmute themselves and ask or type it in the box. Going once, going twice. Nope, that's totally fine. Yeah, thank you so much for the great session. I really enjoyed listening to everything today. So before we wrap up, once again, in case you're considering becoming an AI product manager, I'm putting a link to our upcoming learning program in the chat box. And if you have any questions, don't be shy.
Yeah, and feel free to reach out on LinkedIn. Again, one quick question, Jacqueline, if anyone wants access to these slides, I'm happy to share, just let me know. And I'm happy to kind of just publicly host them somewhere, or just guide me with like, how can I make this information easily accessible to everyone who joined today?
Yes, please feel free to send it. That would be super helpful. And we'll link to it for you. Oh, we have one more question coming in the chat.
Yeah.
Okay, I think someone's just typing. Okay, here we go. Do you see quantitation or pruning reducing the accuracy of the econ device model?
Of an on-device machine learning model, it does. It does. It's a strategy. Okay. Yeah. It's a strategy that you intentionally go for a compromised precision in the interest of speeding up computation and decreasing the model size, like I said. So it will impact the performance.
Okay.
Sure, for sure.
Was the accuracy reduction considerable?
In our specific case, this is a negotiation, right? So it was a tough negotiation for this specific product launch, because by then everyone has gotten used to very high accuracy numbers, like a precision of 85%, a recall of 90%. And that is certainly not impossible, but definitely extremely challenging for on-device ML. In our case, we landed somewhere in the low 70s, which was still acceptable, because again, it is such a difficult problem, and it is so important to launch something fast and have something in place as against just going cold turkey and no protections for young children against unwanted nudity. So with the 70%, the narrative is still 3 out of 10 times we might fail to blur something. 3 out of 10 times we might get this wrong, and we might blur something that's totally unnecessary and upset someone. And that was a negotiation we had to have with leadership and with our growth teams.
Perfect. Does anyone have any other questions before we wrap up? All right, I think we wrapped up a bit early. Yeah, thank you so much again for the great presentation. I really enjoyed it.
This was a lot of fun.
Yeah.
Hopefully folks learned something. That's really my goal.
Yeah, I learned a lot.
Like I said, tip of the iceberg. I'm sure there's a lot here. I'm glad someone flagged that federated learning and on-device ML might be like two different things. So I'm going to go and learn myself. So thanks whoever flagged that. But overall, this has been really fun. Thank you so much for the opportunity.
Of course, of course.
What I love is the structured, the structured way of knowledge, and the beauty is, at least our instructor is the way he is structuring the information, the data, and controlling the time. It's really fantastic. I'm very, very satisfied, and it is a combination of the knowledge, which is more like information or theory, but then we are doing the workshop, and you will not you surprised, but what we are enjoying is that the surprise is practical for the PMs, right? So mostly what we think of that, okay, the workshop or the practical thing for the engineering team, this doesn't work that way, right? So right now what we are working on, say as an example, the PRD, and in parallel we are doing the little workshop as well, where we are brainstorming whether it's a particular use case is rule based versus it should be required the LLM versus other ML model and stuff like that, right? So it's a combination, and if you are able to relate with what you're doing in your office, it gives you a whole lot of sense. And thank you so much, Bijan, because I'm sure that there's a whole lot of brainstorming with you and team has done to produce something like that. It is not just come out of the blue. It's definitely whole lot of behind the scene effort is going on. So thank you so much for you and on the entire team which is working behind the scene, right?